Hi all, welcome back to System Verilog sessions. In this session, I am going to discuss about threads or process in System Verilog. So the agenda is we will be discussing threads or process and fork join any, fork join none, and we will discuss process control. Okay. First, we will understand what is thread or process in System Verilog. You might have heard this word thread or process in operating system. Right? In operating system, we have seen this thread. So what is thread in that OS operating system? Thread is a program or piece of code which is under execution. Similarly, in System Verilog, this thread or process is a piece of code that executes independently. It's also the piece of code, means this process can be a one function or task or statements. Okay, this is nothing but a process. It is a piece of code that executes independently, and the process or thread is enclosed in begin and end. We'll write the piece of code inside the begin and end block. Okay, begin and end. Inside the begin and end we will insert the code, the logic or the function or task. Okay, if begin end is not used, each statement acts as a separate process. So when we use this begin and end, first of all, when we have a multiple statements, right? When we have multiple statements, we will use the begin and end. So if it doesn't have any begin and end, that time the single statement acts as a separate process. It considered as a one single process. Okay. In Verilog, each of the initial and always blocks are spawned off as separate threads that starts run parallel from zero simulation time. In Verilog, this initial and always block, procedural blocks. These are, if we have multiple initial and always blocks are there, that will be executed parallelly with a zero simulation time, right? It will be executed at the zero simulation time parallelly. But System Verilog provides the separate blocks, like parallel blocks. It is called nothing but here fork join any, fork join none. These are all the parallel blocks which System Verilog provides to execute the processes parallelly. Okay, System Verilog provides three different ways to start or control the process. A fork join block also creates different threads which will run in parallel. It creates a different threads which will run in parallel. This blocks, fork join block, fork join block is one main block. It has another two styles, like I said, fork join none, fork join any. We will see one by one what is the fork join, what is the difference between fork join none, join any. Okay, first one is fork join. We will see what is this fork join. Okay, this fork and join are constructs which is used to manage the concurrency. Basically, we will use this fork join none, fork join any. These fork join blocks are used for concurrency because whatever the process you insert the fork join block, that will be executed parallelly. In test bench, we will use this fork join because in test bench we will be having multiple components like generator, driver, monitor, scoreboard. Right? In every component, we will write some code. We will the piece of code that should be run parallelly. All the components, functions or tasks should run parallelly. For that we need fork join. Okay, inside the fork join we can insert the task, we can call the function or task, that all the process which you insert the inside the fork join, that will be executed parallelly, and that means at the same time. So this fork and join, this fork statement will initiate the parallel task, and this join statement will synchronize us and it wait for all the process to complete. Okay, we'll see. All process start simultaneously and join will wait for all process to be completed. Here inside the fork join, whatever you insert, the single statement, the begin and end code, whatever the processes, that will be start simultaneously. At the same time, all the process will be executed, and this join statement will wait. It will wait for all the process to be completed. When all the processes are completed, then only it will come out of the block. Otherwise, it will not going to come out. Okay. In the picture, you can understand. So this is the fork statement. Inside the fork we have a three processes: process 1, process 2, process 3. So after the completion of all the three processes, it will come out of the block. That means after it will come out of the join statement. Here you can see statement 1, statement 2, it will go to the fork join, and here three process 1, process 2, process 3. So process 2 completed, process 1 is completing, and process 3 is completing. See, now process 3 is get completed. Now it will come out of the block, statement 3 will be executed and statement 4 will be executed. So this join statement will wait for all the three processes to be completed. Once all the three processes completed, it will come out of the block. Okay, this is fork join. Now we will see fork join any. As the name suggests, join any. It will wait for any one of the process, any any one of the process to be completed. After that it will come out of the block. Here all the process start simultaneously and join any will wait for any one of the process to be completed. Here it will not wait for all the processes like fork join statement. Here it will wait for only one process which completes first. If the process has the minimum amount of time, that will be completed first, right? So after that completion of that process, it will come out of the block. That's the only difference. Here fork statement, after that we have three processes. Inside the fork we have three processes, same example, okay? Here process 3 is completed first. So it comes out of the block. It is not waiting for process 1 and process 2 to be completed. Process 3 is completed, so it comes out of the block. Here also you can see. See, statement 1, statement 2, after that fork join any block. Here 2 is a minimum amount of time. Process 2 has a minimum amount of time. So after the completion of process 2, it is come out of the block. Statement 3 and statement 4. Once more, see, process 2 is completed. See, process 3, process 4. Like this, fork join any. Okay. Now we will see fork join none. As the name suggests, join none. None means it will not wait for any of the process to be completed. Okay. Inside the fork join none statement, if you have a three processes, it will not wait for any process to be completed. That process will start execution simultaneously only, but it will not wait for the completion of the process. Okay. It comes out of the loop when it enters the fork block. Here all process start simultaneously and join none will not wait for any process to be completed. Here see. Fork statement, after that all the process started executions parallelly only, but it is not waiting for the completion of the processes. It comes out of the block. Here join none. Here you can understand better. Statement 1, statement 2, see. It's not waiting. Once it started the execution, the processes, it comes out of the block. Then everything is going normally only. Statement 1, statement 2. I'll show you once more. 1, 2, see. It started and come out of the block. It is not waiting for the process to be completed. This is fork join none. Okay. Then how we can control the processes or these fork join blocks? For that, system verilog provides two statements. Those are all disable fork and wait fork. Okay. This disable fork is one statement and wait fork is also one statement. So disable fork statement terminates all the outstanding or active processes when it is executed. When this disable fork statement is executed, disable fork semicolon, okay, when this disable fork statement executed, it will terminate all the outstanding or active processes when it is executed, because when that means this active processes means the parallel execution of the processes, it will terminates all the processes, okay, which are executing. So for example, you have a fork join any block. Fork join any block. Join any means what? After the completion of one process, it will come out of the block, right? When it comes out of the block, if you have this disable fork statement, when it comes out of the block and you have a disable fork statement, then the remaining processes, that two more processes are there, no, the process 1 or process 3, that will not go into execute. It will terminate. This disable fork statement will terminate those processes. Okay, that is the use of disable fork. It will use it to disable the active processes. And the wait fork, this wait fork statement is used to wait for all the fork process to be completed. For example, you have a fork join, same example, fork join any, okay, after the completion of one process it will come out of the block. So after that you have a wait fork statement. Consider you have a wait fork statement after fork join any block. After the completion of one process it will come out of the block. So when it reaches the wait fork, when this wait fork statement is executed, that time it will again go for the fork join block. It will wait for all the process to be executed. The two remaining processes will be executed. Then it will unblock the processes, this wait fork. Until and unless the completion of the process, it will not go into unblock. This wait fork statement is used to wait for all the fork process to be completed. This is the use of disable fork and wait fork. I have added few questions, so you can go through that. Can you use fork join outside of an initial or always block in system verilog? Can you nest fork and join constructs in system verilog? What happens if you don't use join after fork in system verilog? Write a logic to mimic the behavior of fork join none using fork join any. And same the logic to mimic the behavior of fork join any using fork join none. Write a logic to mimic the behavior of fork join using fork join any. So the last three questions are actually good questions. You can try this. Use that disable or wait fork or any other methods. So you can convert from this fork join none to fork join any, or fork join any to fork join none. Okay. Thank you.